Anytime you post something you made on the internet, you're gonna catch some flack. And that's fine. People on the internet should be scrutinized, and in some cases, even bullied relentlessly. And I'm certainly no exception. But folks, negative feedback isn't all bad, because spite is a great motivator. Take this comment, for example, and I'm paraphrasing here, but he said something like, "Code for Broke, I'm a deeply closeted man. What you're doing in Unity is impossible, and this game is dead in the water." Okay. Alright. I mean, I have been posting devlogs adding ridiculous features to my open world emergent gameplay RPG like ragdoll broken bones, drop kicks, and suplexes, and not to mention showing footage of NPCs walking in place, so maybe you can't blame the guy, but either way, it's time to embark on a potentially 6-month-long journey of vengeance to prove this twerp wrong. I'm Code for Broke, and if I can do it, so can you. And I think I can do it. I'm pretty sure. Let's start by taking stock of this so-called impossible task and dive into why the feller from the comments section is doubtful. In the game he referenced, Kenshi, a character on one side of the map could be under player control. But if you click on another member of the player's squad that's all the way on the other side of the map, you can take control of them and have them both exist in the world simultaneously, all without those faraway parts being frozen in time. And if you don't understand why that's such a technical marvel, consider this. Every open world segments their world into pieces, sliced into squares like Sicilian pizza. And the reason for that is if you load it all at once, this happens. So instead, they load only the things around the player, so, the game actually runs. And then they seamlessly, or not so seamlessly in many cases, load and unload the game world as the player moves through it. The marvel then is that in Kenshi, the entirety of the world is able to live even though it's not possible that every chunk of it is loaded into memory at the same time. It's something Todd Howard would never dare to dream, something only attempted by independent visionaries, and it's not going to be an easy lift. But rather than just going ahead and implementing it in my game as it is now, instead I'm going to start by making the problem way harder, because I ask God not for lighter burdens, but broader shoulders. So here's the game currently. It already supports loading and unloading map chunks, and it hitches when it does, but it's actually decently fast. But it's only fast because the data is so small. Each world chunk is just 625 vertices, meaning there isn't much room for detail in the terrain, and the density of props, like the trees and rocks, is much sparser than I'd like the final game to be capable of handling. But worst of all is what's called the nav mesh. A nav mesh is a complex 3D object, shown here in blue, and it's the translation of the physical world into usable data for the computer character's navigation. The detail of this mesh determines the quality of the NPC's pathfinding, and it's extremely expensive to compute at runtime like my game is, which is why a lower quality nav mesh was necessary to prevent freezing when chunks load. It worked fine for the first pass, but if I introduce a small complex area like a building's interior, NPCs won't be able to navigate in there at all because there's simply not enough detail to handle an area on such a small scale, which is obviously a massive problem. So I increased the chunk complexity to 2,500 vertices, upped the density of the props massively, and made the nav mesh significantly more detailed. Now we have a proper end state to reach for with much more detail in the world, and a nav mesh precise enough to handle doorways. Here's a side-by-side of the world before and after so you can get an idea of just how much more data we're dealing with. Of course, the chunk load times went from this small hitch, which is already unacceptable, to this completely trash freezing of the game. So how can we have our cake and eat it too? Well, we could have a loading screen if we wanted the game to really suck, and the simplest solution is the Randy Pitchford approach, where I just sort of explain that this is a premium game for premium gamers. But of course, as you know, over here we say AAA, so let's actually fix it by breaking down what's so slow. Each time we move far enough outside of the current location, we have to remove several nearby chunks and load several too. The process for each of those chunks is as follows. First, we have to load the chunk data from a file saved to the disk and convert it from computer gobbledygook into usable information. This already happens in separate threads and uses the fastest serialization library on God's green earth, so it's already the best we can do. That library, if you're curious, is called Memory Pack, and I'll link the repo to that down below. Next, we pass the data to the main thread to create the terrain mesh with the data loaded from disk, since meshes have to be created on the main thread in Unity. If you're not a programmer, just understand that any work performed on the main thread will hold up the current frame to complete, potentially dropping the game's FPS. Next, we spawn every prop, item, and mob, which amounts to thousands of game objects. Now, game objects also need to be created on the main thread, so you can imagine why creating thousands in a single frame might slow the game down. And finally, we generate the nav mesh. And this is the most expensive single operation. Worse yet, it has to happen last because we need all of our props colliders loaded into the scene in order to generate the proper nav mesh. Otherwise, our NPCs would be able to move through trees and rocks. So you can understand why it runs so poorly. We have this series of expensive operations that have to be performed sequentially. To remedy this, we'll need an approach that allows for the work to be done concurrently. Instead of generating the nav mesh as the player moves, I created a tool that generates the nav mesh of each world chunk and saves it to the disk with the rest of the chunk's data. This of course slows down map generation, but it's a one-time cost we can incur outside of gameplay. Now, instead of generating the nav mesh, we simply have to build it with the saved data. This is much faster and allows for more complex nav meshes, but most importantly, it solves our sequence problem. Since the nav mesh already considered the world's props at the time it was generated, we no longer need to wait for thousands of game objects to spawn before we create it. And as an added bonus, and this will be important later, we actually don't need the chunk loaded at all to access the navigation data. So rather than create all of our game objects at once, we can spread the work around like butter on this bread by throttling the number of objects we create in a single frame, which looks like this. If you ever wondered why you see objects pop in when you play video games, it's something like this going on. Of course, to keep the chances of witnessing pop-ins to a minimum, we'll first sort the world props by distance from the player. That way, nearby things are prioritized. With all of this implemented, it was time to finally see the beautiful fruits of our labor, and what the f***? All that effort and it still f***ing sucks and it doesn't work. Cool. So this problem comes down to the nav mesh. Loading it instead of generating it was not the enormous performance boon I expected. But it's also code that belongs to the A-Star pathfinding project, the one and only asset this project uses right now. Obviously, that dipshit in the comments was correct, and it's time to give up. So I messaged the asset's creator, and he told me that the next update would let me use tiles instead of entire graphs. And since the guy that made it, Aaron, is the man, the update came out almost immediately and I went back to the drawing board. Here's how it looks now with the world streaming rewritten to use tiles. Now that, folks, is butter. But the ultimate test is how quickly we can reload an entirely new area. While the player is moving, we're loading the section next to him, which means we're streaming out 3 chunks and in 3 chunks. But if we were to teleport instantly, we'd instead be moving 9 chunks in and out. Since we don't have other squad members we can switch between just yet, I spoofed the teleport button to emulate the effect. Now that's actually pretty damn quick. For reference, I have a 4-year-old Dell gaming laptop with the 3060 laptop GPU, so it's not exactly a powerhouse rig, but generally I'm pretty satisfied with the speed. But of course, we're not dealing with as near as much data as we will when we finally throw all of this back in that guy's stupid face. It's just essential that we get this tech as bulletproof as possible because it will really be the foundation of what's to come, which is why I made many other smaller improvements specific to my implementation I didn't mention in order to speed it up. Now it's time to look at the other significant source of work when loading a piece of the world, the mobs. I started by switching the pathfinding to an entity-based approach, which should be more performant. Back when this game was 2D, it looked like pathfinding was going to be the performance bottleneck, so it's better to get this out of the way now, even if the graphics are the FPS limiter currently. With the new AI, combined with our improved nav mesh, characters should no longer get stuck walking in place. I know, it's cutting edge shit right here. There's not much for them to do, so they just wander around like before, but the behavior is not the focus of this video. With a game that's all about persistence, we don't want to be simply spawning monsters off screen and calling it a day. Instead, we need to actually save and load the mobs as well. This existed in some state before, but was never updated to support 3D. I cleaned up the system to speed it up a bit with some caching, and added support for the 3D characters, loading their race and equipment, which you can see here as some of my beautiful perfect Patreon subscribers pop in and out of the game world. I have a Patreon, by the way, it's like $2, check it out. But loading the characters is the easy part. The harder problem is handling all the computer intelligence information they need to come alive. Consider this. Let's imagine this goblin is that guy who commented on my last video. His character's brain might store a reference to another character, like their pimp, who tricks him out on the street for money. This is all well and good during regular gameplay, but what happens when this guy's daddy they owe money to gets unloaded from the game and they're left as alone in this world as they are in the real one? Well, now you're getting errors every time he needs to call Pepperjack because a John is getting too rough with him. To make matters worse, we can't actually save those references in the code to Pepperjack in the first place. Even if we could guarantee that both the commenter and the goblin that makes sure he's regularly getting turned out are loaded into the game at the same time, if they'd both just been loaded from disk, it wouldn't matter either way, because that link has been severed by the loading. The reason for this is that a game object might represent a character, like this goblin, but it isn't actually that goblin. It's just a vessel that represents it. When the goblin is loaded and unloaded, it has a new game object that represents the same character. To remedy this, we need to generate a globally unique identifier for each character when they're created that persists between saving and loading. This is a pretty simple thing to do, and many programming languages provide this functionality out of the box. Next, we create a hash map of the game's characters, using their identifier as the key. This is essentially a lookup table that maps the character's globally unique identifier to their actual game object. When a character is loaded in, an event is fired which adds their current game object representing them to the hash map. We do the same to remove them when they're unloaded. This means we can instantly retrieve a character loaded in the game world as long as we have their key, regardless of how many times they've been disintegrated and reassembled by our world streaming. But what about the issue with characters being referenced who aren't loaded? Well, instead of completely removing a character when it's unloaded, we can instead put the smallest possible relevant data in its place, like their location. This way, if that commenter is loaded into the game in pursuit of another goblin, or possibly a goat they plan to wed, which resides outside of the game's currently loaded world, they can pathfind towards them without them being there. If they too reach the edge of the chunk, they can simply be unloaded as well and have their data added to the unloaded chunk instead. To wrap it up, when the game is saved, we'll convert every mob in memory to their minimalistic versions in the hash map, and save that with a game file. This way, when characters pop in during the first few seconds of loading, everything is still able to function while those other characters are populated. Now, I quickly want to make it clear that I'm no industry veteran, just a longtime programmer. I don't know if this approach is bulletproof, it's just sort of what made sense in my head, but we'll handle any pitfalls together if you stick around, and if it doesn't work, we'll find another way, that much I'm sure of. But for now, this resolves any of the chunk saving and loading issues I could imagine. But it's still not doing what Kenshi does. We still need it to handle simulated characters that aren't loaded at all. And that's quite literally the final imposing technical hurdle of this entire project, but we'll have to save that for next time. Thanks for watching, everybody. Leave a comment and let me know if you prefer these devlogs heavier on the details, or if I should go back to dancing for you like a clown. I hope everybody had a Merry Christmas and Happy New Year to you all. Peace out, everybody.
Circumstance, raise a baby to a beast like rain and heat, raise a seed in a plant.